Hey, welcome to section 2.2. We're talking about a couple of different other types of graphs, different ways to organize data. So the first one we're going to take a look at is called a stem and leaf plot. The idea with this is you're going to take every number and you're going to split it at the ones column. So for example, if you have a data point of 212, you would take that value and split it right here between the ones and the tens column. Or if you have a 2-digit number like 32, that's going to split right here in the middle. Or if you have 4,128, it's going to split right here. And that line is going to go through all your numbers, and you're going to group them by the tens, hundreds, and thousands on the other side. So let me give you an example. Let's say we have a data set of 21, 31, 32, 35, and 45. All of these are going to split between the ones and the tens column, right here and right here, here and here and here. And the way that you make this plot is you have one big line down the middle, and on the left you're going to put all of your tens, and then on the right you're going to stack your ones. So my first 10 is going to be 2 for 21, and that is going to look like that, 20, and then the 1 on the other side. And then my 30s are going to be, I have two 30s, 31 and 32, so it's going to look like this, 31, 32. So you're stacking all of the 30s out like that. Oh, and I've got 3, so there's 35 as well. So then you're going to have 3 stacked out there. The 40s then are going to be 45. So, and that's how you proceed. If they're hundreds, then you're going to have 2 values over here, your tens and your hundreds place, but always the ones on the right. That's the consistency, is the right-hand side is always your ones digit, and they're stacked out. Sometimes if you have a lot of data, you can have 2 rows of the same tens section. So for example, if I had a lot of 30s, I might organize this like, here's all my 20s, and then I've got 2 rows of 30s. And if you do that, you split them in order. Like this will be all your 30s through your 34s, and then this is going to be your 35s through your 39s. And the ones are always in order. And then you could go on and do your 4s and 5s and that kind of thing, your 40s and 50s and that sort of thing. If you're missing a section of numbers, so like let's say this data set went to 50. No, not 50. Let's say we had a 63 in here. You don't skip immediately to 60. You put a 5 there to hold those 50 spots, even though you don't have any 50s, and you just leave that row blank. And then you go on to the 60s and put the 63. The reason is because another thing we're going to talk about in this section is misleading graphs. And it can be misleading if you don't add those 50s in there, because what that does is it indicates visually that there's a gap in the data. And if you leave the 50s out, somebody might tend to say, oh, that data looks, kind of evenly distributed or something like that, whereas actually there's a gap if they misread the numbers on the left. So we're trying to be as accurate as possible. It's the same reason on the histogram from the last video. We put a little break in there when we don't start at 0, because we don't want that to be misleading. We want to indicate visually that there's a gap in the data there, so that it's more of an accurate read for the person doing the deal. Let me show you a couple calculator things for this. You're doing these kind of by hand, but the main thing is that if you have a large amount of data, you want to use your calculator to sort it, because it does have to be in order. So if you're on ClassCalc, this is just a quick reminder. You've got your data set in here. Ooh, I had it in before and it erased, so let's do it. Remember how you do a set? I'm gonna tap hold the A because you got to name it something. A equals, and then you need to use your square brackets, and then we're gonna enter the data here. Your data is going to be 20. Let's do it this way. 61, 51. 50, 36, 33, 32, 27, 27, 26, 6, and 22. And let's put a 20 in there. Okay, so let's say this is our data set. You want this to be in order. So on your next row, you're going to hit stat. That's right here. And then you're going to come over to, on basic, right here is sort. And then it's saying, what do you want to sort? We want to sort A, so I'm going to tap hold on that A again. And then it's going to give me this data set in order. And that way you can put all your numbers in order in an easy way instead of sorting through a mixed bag of data. Okay. On your TI, you are going to hit stat, remember? And then you're going to select edit. And when you go to, it'll hit you to your entering data lists. And remember the way you hit clear a list. Go up to L1 using your arrow buttons, highlight L1, then click the clear and the down button. That's how you clear out a list. Enter your data, then go back to stat, and the second value here is sort A, and then you're going to select that and hit your second function and your list 1, because that's what you want to sort is list 1, and then that'll put that in order. You can go back into your edit mode and it'll be in order there. So that's how that's the only part the calculator plays in this section, is organizing the data. And then once you're there, let's do this for this data set that we entered. I have a set, and we're starting here at, I've got a bunch of 20s, and then I've got some 30s, and I go all the way up to 61. So I need to include all of the numbers from 20s to 60s, and then I just go in order, make sure the numbers are in order: 20, 22, 25, 25, I put another 5 because there's 2 there, 26, 26, 27, 27, then I'm here at 32, 33, 36, 50, 51, and 61. So that's your data set. Now, what this does is it gives you a visual representation of the data. When it's all mixed up, you might not see any patterns, but when it's like this, you can go, oh, I see, there's a lot of 20s in there. There's not very many 61s, and there's a gap in the middle. So that kind of helps you draw conclusions with the data. The advantage of a stem and leaf plot over histogram is that you can actually see the real data numbers. In a histogram, we remember what we did was we collected those numbers into buckets, and you don't really know what the original data is. The advantage here is you can see those numbers. The advantage of a histogram, though, is it can deal with huge numbers of data. Imagine if you had 100 data points. You wouldn't really want to do a stem and leaf plot because then you got to write out 100 numbers. Whereas a histogram allows you to just collect the numbers into buckets. So histograms are better for large amounts of data, and then stem and leaf are better if you actually want to preserve the original data numbers. All right, so that's one graphing option. Our next type of graph that we want to take a look at is a dot plot. And this is probably something you've seen before. the way that this data is organized, I'll use the same data set that we have here, is it goes on a horizontal line and it's just a number line. So you want to mark out like 20s. Now, how frequently you mark on this is up to you. You don't want to mark 20s to 50s, right? Or it'll all be squashed into one. We want to kind of spread it out. It's kind of like the histogram too. You want to distribute it out in a reasonable pace. So for me, maybe each mark is worth 10. I could have said 5. There's nothing wrong with that. That's a matter of opinion. So 20s, I'm going to go like this, 30s, 40s, 50s, and 60s. And this is a continuous number line. So we're not stacking them on top of each other unless I have a repeat. So for example, my first data point is 20. So I'm going to put 1 dot above 20. Then I'm going to find my next data point is 22. So that's going to be over here a little bit. And I'm trying to estimate, like the middle's 5, right? So 22 is about here. So I put another dot there. Now I've got two 25s. So I'm going into the middle where 25 is, and that's when I start stacking vertically like that. And then I've got two 26s. So I'm stacking like this. Two 27s. I'm kind of tight in there. I maybe, after I've started drawing this, maybe I should have counted by 5s to spread it out a little bit so you could see what was going on better. It's up to you. And then I've got a 32. So I've got a 32 and a 33 and a 36. I've got no 40s. I've got a 50 and a 51 and then a 61. So that's my dot plot. Again, advantages to this are very similar to the stem and leaf. You do see each data point. If you've got 100 of them, you may not want to make a dot for both. But it's a good visual representation. You can see clumps pretty easily and gaps in the data. So, and sometimes you see gaps that you don't see in the stem and leaf. So what I see in looking at this is, hey, there's actually a gap here, but there's a pretty decent gap here as well, which I didn't see. You don't notice up here, but you do notice there. So again, just differences in, what your goal is. The last type of chart we're going to talk about is a pie chart. So a pie chart takes large quantities of number. It's good like a histogram in creating buckets for things. So let's say we have we took a survey to see everybody's favorite foods. So we've got the number of people that like burgers. We had 25 people like burgers. People who want to order a salad was 17. And the people who ordered a chicken sandwich were 32. All right. So we took a survey about like who ordered the lunch menu and whatnot. And then we want to make a chart of this, and we're going to make a pie chart. The way a pie chart works is it's a percentage of the whole. So the way that you do a percentage, the first thing that you're going to do is find a total. So the total is going to be 25 plus 17 plus 32. It's how many people are surveyed in total. So 25 plus 17 plus 32 gives us 74. And then what you want to do is figure out a percentage for each of these outcomes. So for burgers, I have 25 out of 74. And you divide that out, and we want a decimal, and then we're going to turn it into a percentage. So 25 divided by 74 is 0.3, let's call it 0.34. We'll go to the hundredths place, all right? So that means 34% of this circle is going to represent burgers, and I misspelled burgers. All right. Then we're going to do salads. 17 out of 74. 17 out of 74 is, we're going to call this 23.23, which is 23%, moving the decimal 2 to the right. And then chicken, we're doing 32 out of 74, which is 0.43, which is 43%. Now, at the end of the day, we rounded a little bit, but these percentages should add up to 100 if you did it right. So you can check that way. We're pretty close. Then you're going to create a percentage of this circle that is the same as these percentages. So now, if we want to get crazy about it, and if you were doing this, first of all, you'd use an Excel spreadsheet. They'll do this for you. If you were doing it by hand, you'd need to use a protractor and figure out how many degrees. We're not going to be that crazy. We're just going to estimate. So let me give you some helpful things. Obviously, this splits in half. That's going to be 50%. A quarter of it, like this is 25%. So this is, and then the half is 50. And then if you want to, the other one that's kind of helpful is a third. So if you do a third of this, that's roughly 33%. Okay, so I kind of have those in my brain. So what I'm seeing here is this is just a tiny bit more than a third. This is a tiny bit less than a quarter. And then this is the rest. And that's how I estimate my graph. So I'm going to pick one to start with. It doesn't matter what you start with. Here's my center. Here's my starting place. I'm going to go roughly a third. So think the piece symbol for a third. It's straight down and then like this. That's going to be a third. So I'm going to draw my diagonal like right there. And this is going to be burgers. Then I want to do a quarter, which is a right angle. That's going to be salad, and I'm going to be a little bit less. So I'm going to start here, and I'm going to measure if this is a quarter right there. I'm going to go a little bit less than that. So this is going to be my salads. And then the remaining, whoops, I lost my circle. The remaining should be the chicken, which is a little bit less than half. And that's how you make a pie chart. You won't actually have to draw these in your homework. You'll be interpreting them, but I want you to understand how they are constructed as well. So those are our other graphs. The other thing that we're going to talk about in this section is misleading graphs. We've talked about it a little bit up until now. I just want, you're going to have some actual homework questions on it, like what's wrong with this graph? So here are some things that can happen. For example, I could have a histogram like this, and I could have some labels on here. We're just going to do this generally, and I could say, well, so I'm going to start here at 90 and go to 150, and here's my bar chart. Here's my histogram. Okay, and then this. And I don't know, it doesn't matter what we're measuring, you can just make something up. And then I go, well, what do you say here? And maybe you'd look at this and go, oh, okay, well, this category is way lower than this category. And you would be right visually based on this. But here's the thing that you're missing. You're starting at 90 here. So the difference between this bar and this bar is actually not very much if you look at the whole bar. If I had started from 0, these graphs might look like this. Do you see the difference? I can make it look like there's a really big differential between the middle and the last bar, when actually, if you start at 0, there's not. Because I'm just measuring the top in the first graph, but I'm looking at the whole bar in the second. And so that's why we want to label carefully. That's why we want to create gaps when we need to. Here's another one that happens sometimes. People want to make this visual on this pie chart really cool. And so they make it 3D and they tip it. Well, what happens, for those of you who are good at drawing, when you draw on a two-dimensional surface and you want to create depth, what do? You take your lines, your point of focus, and you narrow them as you go. And that creates the illusion of things getting farther away. Well, if you're going to narrow something, it's going to look thinner than what's in front of you on a page. So how you draw these graphs matters. A graph drawn like this is visually more accurate than one, don't laugh at my drawing, than one that looks kind of like, set on its side like this in a really cool way, and maybe it's tipped or something. Because in order for me to create depth, I have to create this wedge over here to look way smaller than this wedge, which maybe it is and maybe it isn't. It creates an illusion there that you don't want to do when you're accurately displaying data. So there's a couple examples of some misleading graphs, and the goal here is just that when you look at data and you look at charts and graphs, that you are aware that somebody may have drawn this in a misleading way, and I want to be aware of what those things are so that I can actually measure data accurately. All right, that's it for today. I will see you next time.